Good afternoon, Algebra 1. So, today what we're going to be doing is we are going to be reviewing a little bit of radicals. So, I'm going to be working through this relatively quickly because I don't want the video to be terribly long. But I'm still going to try and highlight some of the main radicals that we talked about. This is a review. This is pretty much a culmination of everything that we have covered so far. So, the first 7 of these were done prior to spring break. And so this is our 8th edition of radicals. So this is going to deal with basically everything that we have talked about thus far. So if I were to look at number 1, I'm looking for simplifying whatever's inside. This is one of the things that we originally began with. So if I have the cube root of 16x to the 5th y squared, I'm going to think about perfect cubes that go into 16. So if I want a reminder, I could list out all my perfect cubes up here a little bit. 64, 125, 216. Now I think about which of my perfect cubes goes into 16. I know that 8 times 2 is going to get me 16. 8 is my perfect cube. So on the outside, I'm going to bring one of those 2's to represent the 8. And I'm going to draw this over here a little bit. I'm going to leave a 2 on the inside. Now I do always have to remember that my index is going to be a 3. And then from here, if I have x to the 5th, I know that if I want to, some people like doing this, dividing x to the 5th and getting my mixed number. So I'm going to be left with 1 2/3, which means I'm going to have 1x on the outside. I'm going to be left with 2 on the inside. And the last thing is I have 12y, so I could do the same thing. 12 over 3 is going to get me a 4 with nothing else. So I have a y to the 4 on the outside. And so my answer is 2xy to the 4th times the cube root of 2x squared. Moving on to number 2, I'm going to think about perfect squares that go into 50. I can think I have 25 and 2. Now notice the difference between numbers 2 and 1 is A, I'm dealing with only the square root, and B, I have a number on the outside. So what I have to remember is when I'm pulling out additional numbers from the inside, if I pull them to the outside, I have to multiply them together. So I have a 5 that represents a 25. One of the 5's will come out to the front and multiplied by that 2. So I should have a 10 on the outside, and for right now on the inside I just have a 2. So I have 3 A's. That means if I have 3 A's, I'm going to have, if I divide it by 2, I'm going to have 1.5 A's. So I have 1A on the outside. That's looking a little weird. 1A on the outside and then 1A left on the inside. And the last thing I have are K's. I have 8 K's. 2 divided by 8 is going to be an even 4. So I'm going to have 4 K's on the outside. Again, as a reminder, if you do not have any if you're not dealing with cube roots and you just are dealing with square roots, you don't have to write a little 2 here, you can just leave it blank. Alright, so number 3, when we were talking about adding, subtracting, multiplying, or dividing, we wanted to make sure that all of our numbers on the inside were the same before we added or subtracted the outside numbers. So what I'm going to do is I'm going to see if I can simplify them. Always look to simplify first, that was our rule. It can break down 75 into 25 and 3. When I do that, 25 is my perfect square. Pull a 5 out front, so I'm going to have 15 root 3. 125 is 25 times 5. So I can bring one of those 25s out just like I did for the other one. So I'm going to have 20 root 5. So right now, before even going any further, I notice these two will not be able to combine. They're radicands. The number on the inside is different, so therefore I cannot combine them. And for this one, 12 is going to break down into 4 and 3. 4 breaks down into 2 times 2, so one of those 2's is going to come out to the front, so I'm going to have a minus 10 root 3. All I have is a 3 left over. And so now what I'm going to do is I notice I can combine these two. So the only numbers I'm going to combine are those outside numbers. Think about it as like a variable almost. This is like an x, this might be a y because it's a little different. So when I go to combine these, I have 15 minus 10. So I'm going to have, keep the same color scheme going, I'm going to have 5 root 3, and I'm going to keep my other answer, so 20 root 5. And that will be my answer. For the next one, I'm going to do the same thing. I'm going to break them down, and I'm going to see if these are the same. If they are the same, then it works. I'm dealing with cubes here, so I'm going to think of a perfect cube that works. 8 is my perfect cube of choice. Since I bring out a 2 out front, that means I'm going to have 10 altogether, because of the original 5. And then I'm going to break down 500. 500 can be broken down into 125 and 4. What we said here is, the reason why I came up with that, if it ends in 0 or ends in a 5, always see if any of the multiples of 5 work, any perfect square of 5 might work. The other thing is when we're adding or subtracting, we always want to find like pairs. We always want to see if we can create a like pair. So I noticed that if I ended up with a 4 inside of here, I should try and see if I can end up with a 4 on the inside of my next one, because my goal, again, is to make sure that these can simplify. So 125 is 5 times 5 times 5, so I'm going to pull one of those 5s out front. So I have a minus 30 cube root 4. Now I go to combine these, I will subtract the outside, 10 minus 30, negative 20 cube root 4. As we keep going, for number 5, I can think about this as the square root of 18x3 all over the square root of 4x squared. And so when I go to break this down, if I were to do 18x cubed and break that down a little bit further, I'm going to do the number first. 9 and 2. Pull one of my 3's to the outside. So I'm just going to be writing the top part of my denominator here. I know I have a 3 on the outside. On the inside I'm left with a 2. And now the x to the 3. Remember, there's a little invisible 2 here, so 3 divided by 2. I'm going to pull one of the x's out front, and one of them is going to remain on the inside. Now on bottom we have a 4x squared. 4 is a perfect square. X is a perfect square. X times x is going to get me x squared. So on bottom I'm going to have a 2x. Now, my last step for these division problems is we're going to see, can I simplify any further on my division. 2 and 3 are not going to simplify, but my x's will. So I can actually cancel out these x's, and all I'm left with is 3 root 2x all over 2. Alright, number 6. Number 6 is similar to 1 and 2. We're just going to be breaking those down a little bit further. 98 breaks down into 49 and 2. 49 is my perfect square, so 7 is going to end up on the outside, leaving me with a 2 on the inside. I know I have 5 a's, so if I have 5 a's, that means when I divide it, 5 divided by 2 is going to give me 2.5, so 2 come outside, the other 1 stays on the inside. B12, I'm actually going to space this a little bit further because I always seem to run out of space. B to the 12 is going to be 6 that come to the outside, is an even split, so I'm going to not have any left over on the inside. And x to the 3, 1x on the outside, 1x left on the inside, giving me my final answer. Number 7, perfect cubes. So I got to think about what are the perfect cubes that work. 2 is one of them, so I'm going to pull a 2 on the outside. So I have cube root, leave my 2 on the inside. Now I'm going to break down. I have 5 y's, so if I were to take the 5 and divide it by 3, I know that I would have 1 y to the outside, but I'd have 2 y's left over. Z is a perfect split. We have 9. 9 divided by 3 is going to get me an even 3 with no decimals or leftovers. Continuing this, for number 8. Number 8 is a little bit of a multi-step thing. I am going to distribute to each. Now we talked about multiplying. When you multiply, you have to multiply everything. So when I multiply my outsides, my 3 and the 4, to get a 12. On the inside, I'm going to multiply 2 and a 6 to also get me a 12. And then from there, you're going to do the same thing. We're going to multiply 3 by 5 to get me 15, and then 2 by 36, or by 18 to get me 36. From there, I'm going to see if I can simplify these. So if I look, I can simplify or think about what perfect squares go into 12. I have a 4. So 4, I can bring a 2 to the outside, making it a grand total of 24, with the inside just having that root 3 left over. And then my next one, 36, actually is a perfect square, so I guess ultimately when we're doing all this stuff, we should try and think about, is it a perfect square to begin with, before I go forth and try and think of numbers that go into it. But even if you were not to see that immediately and break it down a little bit further, Like if you thought, oh, 4 goes into this, you'd have 4 times 9, and you realize, hey, both of those are perfect squares. Either way, you get to the answer. So 6 is going to be the answer, so we're going to have 15 times 6. Keep a little plus here. 15 times 6 is just going to be a number. It's just going to be 90. So sometimes you're just going to end up with a nice little answer. Like, well, the left-hand side is not so nice. But you end up with a nice 90. So as we move on to number 9, we're going to do some more multiplication again. So multiply my outsides. 3 times 5 is 15. And I'm going to have a cube root of 8. Well, looky here, we have another perfect square, or cube. So I know that 2 times 2 times 2 is going to give me 8. So realistically, or really, I'm just pulling all the 2's out. So I have 15 times 2, which is going to get me a nice clean 30. Number 10, we're going to see if we can simplify this first. And then if we have the same radicands, then we can go ahead and try and add them together. So 40 is going to break down into 4 times 10. So a 2 is going to come to the outside, leaving me with a little 10 on the inside. I have an x squared, which means one of the x's is going to come out to the front again, leaving me with no x's on the inside. And then I'm also going to pull out 2 y's and leave 1 y on the inside because there are 5 to begin with. Now the second part of this, I have a y squared on the outside. I'm going to see if I can break down this next one a little bit further. Again, you're looking for, my goal is, can it get a 10y? That's what I really want it to have. So I know that the outside breaks down into 9 times 10, so I'm going to have 3 y squared, just dropping down what I have up here. And then on the inside, I'm going to have 10, and then I haven't done the other part yet. So then I have x squared to deal with. I got to think about x squared. X squared is a perfect square, x times x, so I'm going to pull an x to the outside, and I notice that the y is going to remain on the inside as well. So now I'm going to look at this problem, I'm going to see, can my radicands, forgot about that, can my radicands simplify? Yes, or sorry, I'm not going to simplify. Are they the same? Yes, they are the same. They're both 10y. Can I simplify the outside? Now, if we look at this, I wrote them in a different order, but 2xy squared plus 3, technically I could write this as xy squared if I'd like. I could have written the y squareds first. It doesn't really make that much of a difference because they have the same exponents for each of these. The degree of the x's are both 1 and the degree of my y's are both 2. I can combine or add the 2 and the 3 to be 5xy squared. I am allowed to do that because my x's look exactly the same. They both have a degree of 1. My y squareds both have a degree of 2. So it works out perfectly. So I have 5xy squared root 10y. And that's my simplified answer. Alright, doing number 11. I'm going to create a little bit more space here. I'm going to break these down. Again, if I want to think about this as the square root of 40 x6, oh, not the square root, the cube root, and then the cube root of 8x to the 6. So I'm going to break these down. If I did 40, that's going to break down into an 8. I'm just going to do the number, and a 5, because I'm dealing with perfect cubes. So what that means, if I write it down here, I'm going to have a 2 on the outside, cube root 5 on the inside, and then I'm going to break that 6 down. The 6 does end up breaking down. I'm going to have an x squared. Alright, 6 divided by 3 is 2. And then on the bottom, 8x to the 6 is actually just going to be the same thing that I had on the outside to the left, because 8 is a perfect cube, and so is x squared. So when I go to simplify this, again, these two are the same, so they're just going to cancel out. So what I'm left with is just going to be the cube root of 5. Moving on to number 12, I'm going to look again, simplify first, figure things out. 144 is a perfect square. You could go ahead and break this down if you wanted to a little bit further, but 12 times 12 is going to get me 144. Similarly, 64 is a perfect square, so this is actually going to be negative 3 times 8. So down below I'm going to write a minus 24, which is going to carry the 12 down. And here I'm going to have a plus 2 times 9. 9 is the square root of 81. So I'd have a plus 18 down here. So now I'll just add these like normal, and I'll get 6. So for number 12, it's more just breaking things down, looking at them. Sometimes you do get perfect squares like this. Sometimes it's really nice. Same with number 13. It's going to follow the same thing, but we're going to do it for cubes. So the cube root of 64 is 4. The cube root of 27 is 3, but I have to multiply it by -5. 125 as well is a perfect cube of 5. And so then when I go to simplify these, I have 4 minus 15 plus 10. So I'm going to be left with a -1. That would be my answer. Alright, so you've stuck with me so far. Let's keep on going with this. On to the back. Now this one's a little bit easier because we got multiple choice, but still going to do the exact same things. Actually, it might not be a little bit easier. It might seem a little bit harder because we got y to the 48. Here's where the division problem comes in handy. If you were to think about this and I divide 48 by 3, I don't want to write out 48 y's and circle all 3 of them, or groups of 3. So instead I could do this method and realize that it's going to be a nice even 16, meaning it'd be letter D. You can definitely write out 48 y's. I wouldn't recommend it. I'd recommend doing it this way, but to each his own. You can do either method. You're going to get the same answer. For number 15, I'm going to simplify this just the square root of everything. So the square root of 100 is 10. If I were to break down the m to the 10, divide the 10 by 2, so I have 5. Divide the 18 by 2, I have 9 left over. B matches up. Now number 16 is a little funky. Number 16, I gotta think about square root of 63, and I'm going to do the square root of 25 over here, and then we'll combine them at the end. So the square root of 63, that could break down into 9 and 7. 9 is a perfect square. Right, so again, we're not thinking about numbers that it breaks down into. Like, this one could break down, I could divide 3 into this, but I want to look for perfect squares that break this number down. Okay, so 9 is a perfect square that breaks it down. If I simplified it, it would be 3 root 7. Take one of those 3's from the 9 outside, and the square root of 25 is just 5. So my new equation, square root of 25 is on bottom, so I'm going to have 3 root 7 over 5. That is my answer. C looks just like it. D is definitely right, but D is not simplified. So we got to think about, can I simplify these? Can I make them in the most simplest form? Number 17. Number 17, we're going to go ahead and break this down. As we know, we should end up with a root 2 since all the answers have a root 2 in it. We know that it has to get down there at some point. So if I were to break down 32, I'm looking again for perfect squares that go into 32. 16 is one of them. It's going to be 4 times 4, so I'm going to take a 4, multiply it by 6, so I'm going to have 24 root 2. That's going to be subtracting 162. Now I know that I want 2 to be one of them, right? 2's got to be the guy left over. So I got to, really, you can just say, what's 162 divided by 2, and then cross your fingers and hope that it's a perfect square. This one, it just so happens to be. It just works out all nice and evenly. If you didn't do that, and it didn't end up being 2, or it wasn't just 2 times 81, it was like 3 times something else, some other perfect square, that's fine. You just know that this wouldn't be simplified, meaning none of these answers would be right. Well, of course the answers would be different if that were the case, but you know what I'm trying to say here. So if I were to break this down, I have a -6 on the outside. I'm multiplied by one of these 9's out here, so I'm going to have a -54 root 2. So now I'm going to do 24 minus 54 should get me a -30. So again, you're always looking to use your context clues, kind of look at the answers a little bit ahead and see what you should be getting down to. Number 18, follow the same thing, but this time we're multiplying, so I'm going to multiply everything on the inside, and there's nothing on the outside to multiply, but it's all good. So on the inside, I'm going to have 3 times 15, which is 45. X to the 5th times x, x to 6. Now I got to simplify it. So, does 45 simplify? Yes, it does. 9 and 5. 9 is my perfect square. Means I'm going to bring a 3 to the outside. I'm going to leave a 5 on the inside. X to the 6 up here. 6 divided by 2. Remember there's a little invisible 2 there. 6 divided by 2 is 3. X cubed. It's going to be on the outside. that should be my answer. Don't mean to box it in. We can just find it right over here. It's going to be letter D. Alright, 2 more to go. Number 19, I'm going to distribute. Right, I'm going to distribute that square root of 2 over to everything. So square root of 2 is going to multiply by each of those. Thankfully, there's nothing on the outside, so we don't got to worry about that. Just going to multiply the numbers on the inside. So I'm going to have square root of 28 plus square root of 4. Right away, we can say this is going to simplify to 2. Now I can break this one down a little bit further. Perfect square that goes in is 4. So my answer is going to look like this, because I have a 7 left over. So 2 times the square root of 7 plus 2, big ol' A. Number 20, again, you're going to multiply everything on the inside. Now again, don't know where that just came from. Again, you can simplify before you go ahead and try and solve them. It is up to you. It is whatever works. You can simplify before, you can simplify after. It's going to get you the same answer. My x's, I'm going to have x3. And my y's, I'm going to have 8 of them. So I got 4, 4. So now if I go to simplify this, break it down a little bit further, I'm only dealing with a square root here. So square root of 16 is 4. It's a perfect square. The square root of x cubed divided by 2, I know I'm going to have 1 on the outside, and I'm going to have 1 left over on the inside. So I know I'm looking for just an x left over, so it can't be d. And then the last thing I got to do is, if I were just to look at A, B, and C real quick, I can finish it out real quick if you just want me to write y to the 4 right here. But if we just were to look at our answers beforehand, A doesn't even include an x, so it couldn't be A. B has 4, C has 8. You know that this number is going to go down at some point, so it can't be C, it's got to be B. That kind of backs up with our answer. You use context clues, you can use your brain, you can use whatever it is that you got. Bring everything to the table. That's all we ever ask. Alright, so that's everything that I got for you all. Hopefully you understand a little bit more than you did before. And of course, if you have any questions, feel free to see me. Have a great day.